Could you help me translate that into allocation? How, and particularly perhaps the experimental unit. Is it a sub-basin, is it a catchment, or is it a group of these? I'm wondering if we were to pursue this, how do we allocate land such that we can develop the appropriate model?
Yeah, I think for the models, obviously, depending on the species that are out there, they're going to have their own natural spatial ranges, right? So you could do some stand level work and be very good for some animals, and then you need to be broader. You could start with a philosophy, though. I'd get the wildlife people together and see if you could figure out a scale that might work. But I'd probably figure you're working on, again, that's where the sub-watershed scale may be helpful. It's large enough, but not so large.
Still makes sense.
But begin to define the units more on the wildlife species than the fish. Because I think what I'm saying is I think the stream should be handled as a unit with its forest attached to it.
Yeah, the two are intermingled, but
yeah, I think your fish people would do a better job trying to figure out how do I recover a salmon population with the trees in there.
But us bird people would be interested too, because there is good information now that shows that fish-bearing streams have a lot more birds around them than streams identical as far as we can make them that don't have fish in them.
Yeah, they don't have to be entirely fish-oriented, but the notion that there's a riparian.
So I think that would be something to be worth monitoring. As if the fish do come back, how does that change the other things that go on? I think you'd find some interesting things.
So just a general sort of reality check question for Hart and maybe Ron and Kate and anyone else Steve, who has thought on this. Is the existing information on, Brad, on wildlife presence, absence, and habitat use?
You'd have to get, I don't know, I can't speak for the forest, but you'd have to get really good at that.
Right.
And one of the first activities that the forest would become really good at is framing the models, and that'll help you figure out what you need to monitor, what you need in the inventory that may not be there, and you have to figure out how to fill in the gap. And you'll have to sort of figure out, well, do I need to be really precise, or can I sort of roughly get that it's got wood on the ground, or,
So the information may not be good enough today to define precisely what the appropriate bin sizes are, so to speak, but you have as a goal to get really good at that and start that process right away.
Yes.
I think from a bird perspective, we have a lot of knowledge of that, and I think we could use parallel information to bring into their, and I think the fish people know a lot too. I think you could go a long ways down the road.
Okay. I just want to.
Yeah, and there would be a fish. To be consistent, there'd be a fish model, like a watershed fish model. I know there's some excellent people working on that, so I know I'm not crazy there. So, but you would have a dedication to that. But there's a lot of information already exists. It would be the synthesis would be in pulling it towards the models and making them sing as opposed, as to what should be there.
Just a point of support on that, the Nature Conservancy is working on a Pacific-wide salmon watershed prioritization process with Trout Unlimited using multiple criteria, salmon life cycle stages, cold water refugia in the context of climate change, for example.
I've got models that I think would meet your criteria for headwater amphibians.
There you go. I'm already
So,
halfway there.
I think we're already partway down the path there, and we just need to build them together with fish models.
We've got plenty of questions to test on these using this stuff. There's not going to be a lack of researchers want to come and join in on this.
I think I like the idea of mega and meta models, and I think there's great promise, and I think it's critical for management questions. I think it works very well here. I appreciate that. My concern as someone who has tried to model vegetation and think about its relevance to habitat is we don't really have a good, robust understanding of habitat dynamics and how we model that. The main thing that people like to use is a serial stage-based system, and it's problematic when you have legacies in the system that reflect an earlier system that was not serial, that was, the fundamental old-growth system under which all this evolved is uneven aged in most of California, including the redwoods. Frequent disturbance. The old growth that's there is not necessarily in any way like what it was before. And so how do you separate the legacies of these older things and even the legacies of logging, where you have incredibly complex habitat dynamics, to make a robust habitat dynamic model, a successional model that's not necessarily serial, unless you want it to be based on silvicultural strategies that are relatively simplistic. And Kevin, I certainly appreciate that, what you said yesterday about that, making systems simpler so they can be understood, has I think a lot of merits to it, even if it's outside maybe the way that the ideal system might be to satisfy environmental values.
But that's the beauty of it. You don't have to be constrained by that if you send every stand on the trajectory. You're controlling what you're trying to create. So you're controlling the disturbance so that you can actually not be confused by it. You can say, this is what I have today.
Yeah, provided that you have sufficient inventory data. And that's always the hard thing when you're building models. It's all those darn uncertainties, and you don't inventory the uncertainties usually because most of the time you're not aware of.
But if you're doing some of those experiments on the spatial scale, you can, even if the total universe of parameters may not have been measured across the whole forest, you could still measure them in your place. You're doing the experiment. If you feel you need more, then we're incorporated. I mean, you're still doing research.
Yeah, there's an underlying concept underneath what both Kate and Steve are referring to, and it's that current ecosystems are so altered either by direct action, logging, or through indirect action, fire suppression as an example, that we don't really have a good sense of what the true relationships between wildlife and habitat are. However, there's a new book of thought called assembly theory, and it becomes even more relevant in the context of climate change, that says ecosystems are very dynamic and they're going to disassemble and reassemble in a variety of ways, and the only thing that we can really do is be explicit about knowing what the relationships are between the species and the habitat, which is what I like.
I'm in that camp.
And I would add to that a little bit that I think in terms of wildlife in the broadest sense, plants, animals, fish, everything, that we probably have a really good understanding of forest succession when you describe it in terms of the dominant trees, dominant vegetation, but I think we don't have a very good handle, maybe in deference to Ron's point, we really don't have a really good handle on what most of the wildlife is doing in forest succession besides those elements. So that's another whole area of research that can be done that would really address some of the wildlife